Welcome to the Cosmo X channel. There is a figure that cosmic experts avoid pronouncing during their public statements about the conquest of the universe. A figure so terrifyingly immense that upon truly grasping it, any dream of transforming ourselves into a species that dominates multiple galaxies crumbles like a tower of sand. That figure is 2,500,000 light-years. The distance to Andromeda, the sister galaxy closest to us. For you to grasp what this really implies, let me show you with an example. Imagine that our Milky Way were the size of a euro coin in your palm. Andromeda would represent another coin placed approximately 3 meters from you. It seems reasonable, doesn't it? But now amplify that proportion to the authentic reality. Each small millimeter of that coin equals 1,000 light-years of frozen, relentless, deadly vacuum. The Voyager 1 probe, the fastest and most distant human artifact that exists, has been traveling for 47 years at more than 60,000 kilometers per hour. During this entire period, it has barely left our planetary system. It hasn't even truly penetrated deep interstellar space. If we directed Voyager in a straight line toward Proxima Centauri, the closest star we have, it would need 73,000 years to reach it. 73,000 years to traverse barely 4.2 light-years. Now take a breath and execute the calculation toward Andromeda. With Voyager technology, we would require around 1.8 billion years to reach the nearest neighboring galaxy, 1.8 billion years. By the time something arrived, if anything arrived at all, our sun would have expanded its gaseous envelope and completely dried the terrestrial seas. Our world would be a scorched wasteland, or perhaps it would have simply ceased to exist. The human species would be a vestige buried in oblivion if there remained anything capable of remembering it. But perhaps you consider that Voyager represents obsolete technology, that we are capable of moving faster, and in technical terms you're not wrong. The most hopeful projections of latest generation space vehicles using photonic navigation or atomic fusion engines could achieve between 10 and 20% of light speed. Impressive figures compared to what we currently possess. With 20% of the speed of light, we would manage to reach Andromeda in approximately 12.5 million years. 12.5 million years. Since the first hominids began to move upright on the African continent until the present, only 7 million years have elapsed. The entire trajectory of our species, from the first stone tools to mobile devices and space aircraft, has occurred in a minuscule portion of that span, and we are referring only to the one-way journey. The truth is that the void between galaxies doesn't resemble the void between worlds or even between suns. It is a precipice of a magnitude that our minds adapted for hunting on the African plains and searching for food in the treetops simply cannot assimilate. When scientists of the firmament speak of spatial void, they don't allude to a room without objects. They allude to expanses where you could move for millions of years without finding absolutely anything, not a particle of cosmic dust, not a solitary atom, nothing, only total blackness and extreme cold at 2.7 degrees above absolute zero. To aggravate the situation even more, that precipice doesn't remain motionless. It doesn't represent a calm sea that we can navigate with eternal patience. The intergalactic void constantly dilates, extending like an elastic band that someone stretches ceaselessly. Each second that passes, Andromeda and we should distance ourselves more, except that the mutual gravitational attraction between both galaxies is so powerful that in reality we are approaching. But we will address that contradiction later, because what's crucial now is to understand that we inhabit a cosmos where the separations are not only colossal, but actively adverse to any attempt to traverse them. Reflect on this. Light, moving at 300,000 kilometers per second, requires 2.5 million years to travel from Andromeda to your retina. Light lacks mass. It doesn't require fuel, it doesn't experience fatigue, it doesn't age. It is literally the fastest thing there can be in the cosmos according to the principles of physics, and yet it needs 2.5 million years to complete that journey. When you observe Andromeda in the nocturnal celestial vault, you are contemplating its appearance when our Australopithecus ancestors were barely beginning to create the first instruments in Africa. Now imagine trying to launch a ship with human beings with all the infrastructure required to preserve them alive. Food, liquids, oxygen, radiation shielding, redundant vital maintenance systems, propellant for trajectory adjustments, repair equipment, habitable zones, recycling systems. The weight of all this would exponentially multiply the energy required to achieve considerable speeds. We are not referring to minor differences. We are talking about each extra kilogram demanding colossal quantities of additional energy. NASA and ESA experts have designed theoretical missions toward the closest stars, not toward galaxies, simply toward stars in our immediate vicinity. And the figures are disheartening. The Daedalus project from the 1970s estimated that a robotic mission toward Barnard's star at 6 light-years distance would need 54,000 tons of helium-3 fusion fuel. 54,000 tons for a 50-year automated voyage toward a relatively close star. Amplify that by the demands of a crewed journey toward a distant galaxy, and the figures transform into literally astronomical in the most genuine sense of the term. There exists another dimension of this problem that is rarely mentioned: orientation. At interstellar separations and much more at intergalactic separations, navigation failures amplify exponentially. A failure of 1/1000th of a degree in your initial direction could cause you to miss your destination by millions of light years. And there is no GPS in the intergalactic void. There are no orientation satellites. There are no transmissions that you manage to employ for course adjustments in immediate time. You would be orienting yourself with stars that will have modified their location by the time you reach the destination, employing calculations that must anticipate the locations of celestial bodies millions of years into the future. Computer simulations of hypothetical intergalactic crossings reveal another terrifying dilemma: gravitational deviation. Although the void between galaxies is predominantly uninhabited, it isn't totally uninhabited. Dark matter exists, despite the fact that we don't perceive it visually. Weak but existent gravitational fields exist. Throughout a trajectory of millions of years, these minuscule gravitational influences would accumulate, altering your course in ways impossible to anticipate with exactitude. It would be comparable to trying to execute a perfect billiard shot on a continent-sized table with the ball rolling for 1,000,000 years. The possibilities of succeeding are statistically equivalent to zero. And then there's the temporal component. Even if we solved all the technical obstacles, even if we manufactured an aircraft capable of moving at 20% of light speed, even if we managed to preserve generations of human beings alive for millions of years, what would we find upon arriving? Andromeda won't be where we observe it currently. It will have moved. The stars in its interior will have emerged and perished. The civilizations that could have inhabited there will have emerged and become extinct 1,000 times. We would be chasing a ghost, a mirage of ancestral light, trying to capture something that ceased to exist in that configuration eons ago. The stark truth is that intergalactic separations are not merely enormous. They are so incomprehensibly colossal that they transform any imaginable technology into a useless artifact. It doesn't matter how evolved we become, it doesn't matter what we find, it doesn't matter how long we endure as a species. The abyss between galaxies is for all practical purposes infinite. This represents our first encounter with the limits of our cosmic prison. The separations between galaxies do not constitute an impediment that we can overcome with sufficient inventiveness or tenacity. They are a definitive wall erected by the essential geometry of the universe itself. And this is only the first of numerous walls we will find. Because even if we could solve the dilemma of separation, even if we could make light years lack importance, there are even more essential obstacles awaiting us. Obstacles that make distance look like the least of our inconveniences. The true question is no longer how will we reach other galaxies. The question is, why was the cosmos structured in such a way that ensures we will never manage to do it? Intergalactic separations turn out to be terrifying, but at least they represent a conceptual dilemma that we can visualize solving with sufficient time. Perhaps multigenerational ships, perhaps cryogenics, perhaps something we haven't yet developed, but there exists a much more essential, much more definitive obstacle that annihilates even the most hopeful fantasies. An obstacle that cannot be overcome with inventiveness, patience, or future technology. That obstacle is energy, specifically the magnitude of energy required to move any body with mass at speeds that would make intergalactic crossings remotely feasible. And when I mention magnitude of energy, I don't allude to a lot of energy. I allude to magnitudes so obscenely immense that they cause all of humanity's energy reserves to look like the spark of a lighter compared to the Sun King. Let's begin with a concrete figure that will help you grasp the magnitude of the dilemma to accelerate a space aircraft weighing approximately 1,000 tons. Approximately the mass of the International Space Station to 50% of light speed, you would require approximately 1.3 billion terajoules of energy. To put it in perspective for you, that represents more energy than all the electricity produced by all humanity in its entire trajectory. All the energy from all the power plants, all the atomic installations, all the solar collectors, all the wind turbines, all the burning of coal, hydrocarbons and gas since we discovered fire. All of that combined would not be sufficient to accelerate a single ship the size of the ISS to half the speed of light. And that represents only the acceleration still. You must decelerate when you reach your destination, which demands exactly the same magnitude of energy. So double that figure and remember, we are referring to achieving only 50% of the speed of light, which implies that the journey to Andromeda would still require 5 million years. But the dilemma becomes exponentially worse as you try to move faster. This is due to one of the most beautiful and merciless equations in physics, the relativistic kinetic energy equation. At reduced speeds, energy increases linearly with speed. You double the speed, you quadruple the energy. But when you approach light speed, the relationship transforms into exponential, then superexponential, and finally asymptotic. That is, the more you approach the speed of light, the more energy you demand, and that quantity grows toward infinity. To achieve 90% of light speed, you would require approximately twice the energy as to achieve 50%. For 99% you demand 10 times more. For 99.9% you demand more than 20 times the energy of 99%. And for 99.99% the figures transform into literally astronomical. We are referring to energies equivalent to the complete production of the Sun for years. Experts have calculated that to accelerate a 1,000-ton ship to 99.99% of light speed, you would require approximately 4.2 billion tons of perfect fuel in an ideal mass-to-energy conversion reaction. 4.2 billion tons. For reference, all of humanity consumes approximately 14 billion tons of oil equivalent annually. You would demand almost a third of the annual energy consumption of all human civilization, but not in the form of oil or coal, in the form of ideal fuel with 100% efficient mass-to-energy conversion. And herein lies the dilemma. That ideal fuel doesn't exist. The most efficient reaction we know is the annihilation of matter and antimatter. When 1 kilogram of matter meets 1 kilogram of antimatter, they annihilate each other, transforming into pure energy according to Einstein's celebrated equation, equals mc squared. It's ideal in theory. Each gram of matter converts into approximately 90 petajoules of power. But antimatter doesn't appear spontaneously, it must be produced. And producing it requires precisely the same amount of power that it will later deploy when destroyed. It's like filling a gasoline container using the same power that you expected to obtain from that gasoline. You end up at zero balance. Even worse, our present techniques for antimatter generation are terrifyingly inefficient. For every million units of power we inject, we obtain only a few units of useful antimatter. The remainder evaporates in the form of heat, emissions, and side reactions. CERN, the most formidable particle accelerator in our world, manages to generate about 10 million antiprotons each minute on its optimal days. It seems astonishing until you do the numbers. You would need CERN to work without pause for approximately 100 million years to generate just 1 gram of antimatter. Only 1 gram. And keep in mind that we need billions of tons. Even if we manage to magically resolve the generation question, conserving antimatter constitutes another completely different nightmare. Antimatter must not touch conventional matter or it destroys itself in an instant. You need incredibly intense electromagnetic fields to keep it floating in total vacuum. These electromagnetic fields require constant power. And if anything malfunctions, if a blackout occurs, if a microscopic fragment penetrates your container, the totality of your antimatter destroys itself instantaneously in an explosion that would make thermonuclear weapons minuscule. But let's suppose we solve all of these questions. Let's suppose we discover a procedure to generate and conserve enormous volumes of antimatter efficiently. We still confront a basic question, Tsiolkovsky's rocket formula. This formula, developed at the beginning of the 20th century, exposes a merciless reality regarding space expeditions. The majority portion of your vehicle's mass is propellant, and that extra propellant needs more propellant to propel it, which needs still more propellant to propel that propellant, and so on indefinitely in a destructive circle for an intergalactic expedition. The ratio of propellant to operational payload becomes ridiculous. Certain calculations indicate ratios of 1 million to 1. For every kilo of operational payload, apparatus, personnel, provisions, vital liquid, you would need 1 million kilos of propellant. And that million kilos needs to be propelled equally, which requires more power, which requires more propellant. It constitutes a contradiction that amplifies to the limit of numerical collapse. Technicians have proposed ingenious answers, Bussard ramjet propellers, for illustration, which would capture hydrogen from the void between stars and use it as propellant for permanent nuclear reaction. Theoretically, you would never exhaust the propellant since you would be capturing it during your displacement. Question resolved, correct? Not at all. The most current numbers evidence that the concentration of hydrogen in the void between stars is so minimal that you would need a collector the volume of an entire nation to capture profitable volumes. And in the void between galaxies, where the concentration is 1,000 times lower, you would need a collector the volume of a complete stellar system. The structural tensions needed to keep such a thing cohesive at relativistic rhythms would pulverize it instantly. Some have proposed photonic navigation pushed by gigantic laser emitters from our world. The concept is that the vehicle doesn't carry propellant. The power emerges from emitters that push it from the origin, but the numbers again turn out crushing. To propel a vehicle of reasonable dimensions to relativistic rhythms using laser emitters, you would need a laser plant that would devour the entire energy generation of our star, without exaggeration. And you would need to keep that emitter impeccably directed on a vehicle that is distancing itself at relativistic rhythms for decades or centuries. An orientation failure of 1,000th of an instant and you lose the vehicle definitively. There is also the proposal of atomic detonations. The Orion Initiative of the 1960s proposed throwing atomic bombs behind a vehicle and riding the explosion. It would work theoretically. Actually, it constitutes one of the scarce propulsive proposals that we could genuinely build with present techniques. The question lies in that you would need millions of atomic bombs. Millions. For an expedition toward the most immediate star. For an intergalactic expedition, you would need more atomic bombs than elementary particles on our planet. Obviously unfeasible. Every proposed answer finally crashes against the identical obstacle. The power demanded for intergalactic expeditions surpasses the power accessible in the mechanism we wish to utilize. It's similar to trying to drain the ocean using water from the ocean. Regardless of how efficient your pumping system is, it will never operate because the mission requires more means than what the mechanism manages to supply. And this transports us to the most crushing confirmation of the totality. Even if we manage to build a perfect antimatter propeller, even if we manage to resolve all of the technical questions, even if we manage to capture volumes without restriction of power from our star or from nuclear reaction, we would continue crashing against an absolute obstacle. The light limit doesn't simply constitute a speed ceiling, it constitutes a power ceiling. As you approach the light limit, the power demanded to accelerate even 1 additional gram approaches toward infinity, textually toward infinity. No matter how much power you accumulate, it's never enough to reach the light limit, since the cosmos has installed an infinite power barrier right at that threshold. Physics doesn't act with cruelty, physics acts with absolute character. The norms that make it possible for power to exist, that make it possible for elementary particles to exist, that make it possible for you to exist reading this text, are identically the norms that ensure you will never manage to accelerate sufficiently fast to make intergalactic expeditions feasible. It doesn't represent a question of techniques, it doesn't represent a question of duration or perseverance or creativity. It represents a question of essential principles of the cosmos that cannot be broken, twisted, or circumvented. The energy obstacle doesn't constitute an impediment that we can eventually overcome. It constitutes a definitive barrier engraved in the very fabric of existence. And this barrier possesses an even more crushing implication that we haven't addressed yet. An implication that causes the dilemmas of separation and power to look insignificant in contrast. Since even if we solved both, even if we found a miraculous procedure to move quickly, without unattainable power, there is a third obstacle awaiting us. An obstacle that ensures that any intergalactic explorer would be sentenced to a fate more terrible than extinction, the total and perpetual isolation from the remainder of our species. Visualize that we finally achieve it. Visualize that we solve the questions of separation and power with some prodigious future technique. We manufacture a vehicle capable of moving at 90% of the light limit, and we launch it toward Andromeda with a crew of audacious explorers. It constitutes the most glorious instant in human trajectory. The transmissions emit while the vehicle distances itself from our world, as it crosses the trajectory of our satellite, as it surpasses the red planet. The gas giant abandons our planetary system and penetrates into the abyss between stars. And subsequently something happens that nobody totally foresaw in the simulations. Something that the experts understood would occur, but whose existential consequences had never truly been addressed publicly. The transmissions from the vehicle begin to arrive more and more distanced, not because the crew is transmitting fewer communications, but because each transmission requires more time to arrive. After 1 year, there is a 1-year delay. After a decade's delay. After a century, your distant descendants are receiving communications from individuals who died generations ago. But this constitutes only the beginning of the dilemma. The authentic terror begins when you reflect on what happens to electromagnetic transmissions at relativistic rhythms. When something moves extremely fast, distancing itself from you, the electromagnetic waves it emits lengthen. This is the celebrated Doppler effect, the same one that causes an ambulance's sound to sound higher when it approaches and lower as it moves away, but at rhythms close to the light limit, this effect not only alters the tone, it totally annihilates the transmission. A radio transmission sent from a vehicle moving at 90% of the light limit experiences an extreme redshift. The frequencies lengthen so much that a transmission sent on commercial radio frequency would arrive at our planet as electromagnetic waves of extraordinarily reduced frequency, almost imperceptible, and this worsens exponentially with rhythm. At 99% of the light limit, transmissions lengthen so much that they become practically undetectable, even with the most sensitive radio telescopes. But the Doppler effect constitutes barely the first dimension of this communicational hell. There is something considerably more terrible awaiting: time dilation. Einstein demonstrated that time doesn't turn out invariable. Time elapses at distinct rhythms depending on how fast you are moving. At conventional rhythms, this divergence is microscopic, insignificant, but at relativistic rhythms, the divergence becomes dramatic, crushing, existential. For a vehicle moving at 90% of the light limit, for every year that elapses for the crew, approximately 2.3 years elapse on our planet. It seems manageable, correct? A desynchronization that you could compensate for in your numbers, but at 99% of the light limit, the ratio is 1 to 7 for every year of the crew, 7 years in our world at 99.9%. It's 1 to 22 at 99.99%, it's 1 to 70. Now reflect on what this implies for communication. Visualize that you form part of the crew and you transmit a communication to our world expressing, the situation is stable. We have finalized the first year of the voyage. That communication moves at the light limit back to our planet. But while that communication moves, our planet continues aging considerably faster than you. By the time your communication of first year finalized arrives at our world, decades have elapsed. Your offspring are elderly. Your grandchildren possess grandchildren. The planet you abandoned no longer remains. And when our world replies to your communication, its reply requires decades to reach you. But for you, perceiving it in subjective chronology, it seems that our planet simply ceased to reply. Communications arrive progressively more distanced, progressively more desynchronized with your existence. The replies you receive correspond to interrogations you formulated months ago according to your chronometer, but which were transmitted decades ago according to our world's chronometer. An investigation divulged in 2024 by experts from Oxford Institution modeled precisely this scenario and reached a devastating determination. At rhythms required to make intergalactic expeditions feasible, reciprocal coherent communication becomes physically unviable, not arduous, not intricate, unviable. The chronological desynchronization turns out so severe that any attempt at dialogue collapses into a disorder of communications arriving in the wrong sequence, with lost contexts, with allusions to happenings that still haven't occurred or that occurred so long ago that they are no longer pertinent. Visualize trying to sustain a dialogue where each word you pronounce requires a year to arrive at the other person and their reply requires another year to return to you. But additionally, time is elapsing at divergent rhythms for both. It would be like trying to dispute chess by postal service if the missives arrived randomly out of sequence and the other person aged a decade for each move you execute. But there is an even more profound dimension of terror in this dilemma. It doesn't constitute only that communication is arduous or delayed, it's that finally it becomes literally unviable to preserve a coherent transmission. Electromagnetic transmissions lose power as they move. They disperse, they weaken, they contaminate with cosmic interference. At separations between stars, you demand colossal antennas and enormous transmission powers only to transmit elementary communications. At intergalactic separations, the magnitude of power required to transmit a perceptible signal becomes prohibitive. Experts estimate that to transmit an elementary radio communication from Andromeda to our planet that could be captured with our most formidable radio telescopes, you would require an antenna the volume of a world, transmitting with a power comparable to the complete generation of various stars. And that represents only to transmit something comparable to a few words. To transmit moving images, sound, intricate scientific information, you would require powers so colossal that fundamentally you would require a Category 2 civilization in the Kardashev classification, one capable of capitalizing all the power of its star. And this supposes that both extremes of the communication are immobile. But keep in mind, the vehicle is moving at relativistic rhythms. The Doppler effect is distorting all frequencies. Time dilation is desynchronizing all chronometers and the separation is incrementing constantly. Each instant that elapses, the vehicle is millions of kilometers more distant. Each day tens of billions of kilometers, each year separations that defy assimilation. There is also another phenomenon that is rarely alluded to, relativistic light aberration. At rhythms close to the light limit, your perception of the cosmos transforms radically. The stars in front of you seem to agglomerate into a resplendent point while the stars behind you fade. The complete celestial vault distorts and the transmissions you capture from our world don't arrive from where you anticipate. They arrive angularly deviated due to your extreme rhythm. You demand to calculate constantly where to orient your antennas, not toward where you perceive our planet, but toward where our planet will be when your transmission arrives, compensating for both your displacement and time dilation. The complexity of preserving communications in these circumstances doesn't turn out only technical, it's existential. You are trying to preserve contact with a planet that ages at divergent rhythms, that is separated by distances that cause transmissions to require years, decades, or centuries to move, where each communication you transmit constitutes a chronological capsule of a version of you that technically no longer remains by the time the communication arrives. The psychology specialists who have investigated extreme isolation in Antarctica, in atomic submarines, in space simulation missions, all concur on something. Humans demand regular social bonds to preserve mental stability, not occasional, regular, daily, ideally. When that bond delays excessively, when replies require weeks instead of instants, human psychology begins to fragment. Individuals develop depression, anguish, psychotic disorders. Now visualize that replies don't require weeks, they require years, decades, that each communication you transmit constitutes essentially a letter thrown into the void, without authentic expectation of meaningful reply, that each day that elapses distances you more from the only species with which you manage to communicate genuinely. that you are sentenced to elapse the remainder of your existence and the existences of your offspring and the existences of the offspring of your offspring in an isolation so absolute that no human individual in trajectory has ever experienced. This doesn't constitute exploration, it constitutes banishment. It constitutes a voluntary exile toward a solitude so abysmal that it transforms into a modality of extinction in life. You would continue being alive, you would continue thinking, perceiving, existing, but you would be totally, irreversibly separated from everything that causes human existence to possess meaning. Without dialogues in immediate chronology, without affection shared in the instant, without the capacity to console someone who suffers or celebrate with someone who triumphs. And herein lies the most merciless contradiction of all. The same speed that makes the journey possible is the one that makes the bond unviable. To move sufficiently fast so that the intergalactic journey is feasible within a human existence, you demand to move so fast that communication breaks totally. You don't manage to possess both things. It turns out physically unviable. You manage to reach another galaxy or you manage to preserve contact with the origin, but you don't manage to execute both things. The cosmos compels you to select, and both options constitute variations of catastrophe. Intergalactic explorers wouldn't represent pioneers, they would represent specters, entities trapped between planets, without capacity to return to the one they abandoned nor truly belong to the one they try to reach. Wandering through the abyss for generations, transmitting communications that nobody will reply to in time, capturing echoes of a planet that perished long ago, sentenced to a modality of existence that no conscious individual should ever experience. And this cosmic solitude doesn't constitute the only dilemma the explorers confront. Since while they float in that absolute silence, while our planet ages at divergent rhythms and communications fade in cosmic interference, the cosmos itself is actively operating against them in a way that causes all previous dilemmas to look insignificant. An invisible, unstoppable power that ensures that each instant they spend moving, their destination distances itself faster than they are approaching. There is a power in the cosmos that few truly comprehend. A power so peculiar and counterintuitive that when it was first found, even the best experts on the planet refused to accept it. A power that doesn't push nor drag, that doesn't possess an identifiable origin, that cannot be blocked or circumvented. A power that is at this precise instant distancing each galaxy from each other galaxy at rhythms that constantly increment. That power constitutes the dilation of the void itself. In 1929, astronomer Edwin Hubble executed a finding that transformed forever our assimilation of the cosmos. He detected that practically all distant galaxies were distancing themselves from us. And the most peculiar of all is that the more distant a galaxy was, the faster it distanced itself. It didn't turn out that galaxies were moving through the void, it turned out that the void itself between us and them was dilating, stretching like a cosmic elastic band that someone extends ceaselessly. The relationship he found is currently denominated as the Hubble-Lemaitre law in recognition of Hubble and Belgian clergyman Georges Lemaitre, who initially proposed the concept mathematically. The law turns out deceptively elementary. For every 3.26 million light-years of separation, galaxies distance themselves approximately 70 kilometers per second faster. 70 kilometers per second per megaparsec in astronomical nomenclature. It seems a diminutive figure until you begin to execute the numbers. Andromeda, at 2.5 million light-years, should be distancing itself from us at approximately 54 kilometers per second due to dilation. Actually, it's approaching at approximately 110 kilometers per second since the reciprocal gravitational attraction between both galaxies turns out sufficiently intense to overcome dilation. We represent the anomaly. Andromeda and our Milky Way are destined to merge in approximately 4 billion years. But more distant from our local galaxy assembly, more distant from the scarce dozens of galaxies that are gravitationally linked to us, dilation prevails totally. A galaxy at 300 million light-years distances itself at approximately 6,500 kilometers per second. A galaxy at 3 billion light-years distances itself at 65,000 kilometers per second, and here is where everything collapses completely at approximately 14 billion light-years of separation. galaxies are distancing themselves from us at the light limit. Absorb this again because it turns out crucial. At 14 billion light-years of separation, approximately the dimension of the observable cosmos, galaxies distance themselves at 300,000 kilometers per second, and more distant from that threshold they distance themselves faster than the light limit. This doesn't contravene special relativity since galaxies aren't moving through the void faster than light. It turns out the void between us and them that dilates faster than light manages to traverse it. This constitutes the definitive cosmic trap. Visualize that you're on a colossal cosmic exercise band that constantly accelerates. It doesn't matter how fast you move. The band moves faster. Finally, it reaches a threshold where even moving at the maximum feasible rhythm, the light limit, you continue retreating instead of progressing. That represents exactly what potential intergalactic explorers confront. Currently, Andromeda turns out special since it's sufficiently close so that gravitational attraction overcomes dilation. But let's suppose we orient toward another galaxy, one that is more distant, the Triangle Galaxy, for illustration, at approximately 3 million light-years, or Galaxy M87 at approximately 55 million light-years. For these galaxies, dilation is actively operating against us. The numbers turn out brutally elementary and crushing. If we manufactured a vehicle capable of moving at 99.9999% of the light limit and oriented it toward a distant galaxy during the journey, the void between us and that galaxy would continue dilating. Each year we move, the objective separation increments not only by the void we still haven't traversed, but by the new void that is being generated while we move. It turns out comparable to trying to swim toward the coast while the current drags you toward high seas. Except this current not only drags you backward, it constantly accelerates. Each stroke you execute, the current becomes a bit more intense and there exists no way to swim faster since you're already swimming at the maximum rhythm physics makes possible. An investigation from the California Institute of Technology in 2022 modeled precisely this scenario. They estimated that for a galaxy located at more than 4.6 billion light-years of separation, denominated the Hubble horizon, it turns out physically unviable to reach it no matter what technique you employ. Even moving at the light limit during the entire present age of the cosmos, you would never reach it since the intermediate void is dilating faster than you manage to traverse it. This implies that approximately 94% of galaxies in the observable cosmos are already more distant from our reach, not because they turn out excessively distant in the conventional sense, but because the void is dilating so fast that we will never manage to transmit even light to reach them. They turn out observable in the sense that we manage to perceive the light they emitted billions of years ago, but they turn out unreachable in the sense that we will never manage to visit them. And this worsens. The dilation of the cosmos doesn't turn out constant, it's accelerating. In 1998, two independent teams of astronomers found that the cosmos not only is dilating, but that it's dilating faster each year that elapses. They obtained the Nobel Prize in Physics in 2011 for this finding. The cause of this acceleration is attributed to something denominated dark energy, a mysterious modality of energy that permeates all the void and compels the cosmos to dilate more and more fast. The practical implication of this turns out terrifying. The horizon of reach is contracting. Galaxies that we would theoretically manage to reach currently if we possessed the technique will be more distant from our reach in a billion years. Galaxies that will be more distant from our reach in a billion years will be more distant from our observable horizon in 10 billion years. The accessible cosmos is contracting while we converse, gradually fading behind a cosmic event horizon that we will never manage to traverse. Reflect on the existential implications of this. There are civilizations in distant galaxies at this precise instant. Civilizations that perhaps are observing our nocturnal celestial vault, questioning if there is anyone else out there. And we are here questioning the identical regarding them, but due to cosmic dilation, we will never find each other, we will never exchange transmissions, we will never share knowledge. We are perpetually isolated, not by selection or lack of technique, but by the essential structure of chronological space. And this applies even to galaxies within our present theoretical reach. Andromeda, which we would manage to reach since gravitational attraction overcomes dilation, constitutes the scarce anomaly for practically any other galaxy, even those within hundreds of millions of light years. Dilation implies that the journey would require considerably more duration than what the present separation suggests, since you would be pursuing an objective that constantly distances itself. Visualize orienting yourself toward a galaxy at 500 million light-years of separation with a vehicle moving at 99.99% of the light limit. Computing only the journey duration without contemplating dilation, you would require approximately 500 million years. However, during those 500 million years, the void has dilated. The meta-galaxy currently is approximately 600 million light-years of separation. You demand to move another 100 million years, but during those 100 million years it dilates more. It constitutes a competition you never manage to overcome since the goal distances itself faster than you manage to move. Mathematicians denominate this an asymptotic limit. You approach your goal, but you never reach it totally. It turns out comparable to trying to reach the horizon line. You walk toward it and it constantly seems to remain at identical separation, constantly unreachable, constantly more distant from your next step. And then there's the even more somber reality of accelerated dilation. Cosmologists anticipate that in approximately 100 billion years, due to the continuous acceleration of dilation, all galaxies outside our local assembly will have disappeared more distant from the cosmological horizon. Their luminosity will never reach us. They will fade from the nocturnal celestial vault as if they had never remained. Future civilizations in our galaxy will observe the vault and perceive only blackness. They will possess no way to understand that there once remained a more extensive cosmos filled with billions of other galaxies. This constitutes perhaps the most solitary feasible modality of cosmos. One where intelligent existence inevitably emerges, observes the cosmos and remains perpetually isolated from any other intelligent existence by powers it cannot control, overcome, or even resist. The cosmos is structured by pure casualty of its essential principles to preserve civilizations isolated on progressively more diminutive cosmic islands. But herein lies the final contradiction. Even if we could somehow overcome dilation, even if we found a procedure to move faster than the void dilates, we continue crashing against the obstacles we already addressed. Power continues being unviable, separations continue being invincible, communication continues being unviable. The dilation of the cosmos doesn't constitute the only dilemma. It turns out simply another nail in the coffin of intergalactic dreams, another essential principle that expresses no in the most definitive feasible way. And this principle possesses a silent accomplice, another component of physics that ensures our imprisonment. An accomplice that has nothing to do with separations or power or cosmic dilation. An accomplice that is within the very formulas that expose how time, void, and rhythm operate. Einstein's formulas, which when you assimilate them totally reveal that even in a cosmos without dilation, even with infinite power, we would continue being prisoners of our own galaxy for causes that constitute perhaps the most essential of all. In 1905, a 26-year-old employee of the Swiss Patent Office published a document that would transform forever our assimilation of the cosmos. Albert Einstein, a name we all currently recognize, proposed something so radical, so counterintuitive, that even currently, more than a century later, our minds battle to accept it totally. He proposed that time doesn't turn out invariable, that void doesn't turn out fixed, that both turn out malleable, flexible, dependent on the observer. And most crucial for our discussion, that nothing with mass manages to reach the light limit. This last declaration doesn't constitute a recommendation, it doesn't constitute a technical restriction we can overcome with sufficient creativity. It constitutes an essential principle of the cosmos, as inviolable as the preservation of power or the fact that 2 plus 2 turns out equal to 4. And this principle possesses devastating implications for any civilization that fantasizes about intergalactic journeys. The central dilemma lies in a formula denominated the Lorentz factor, symbolized by the Greek letter gamma. This formula exposes how time, mass, and length transform as you approach the light limit. At conventional rhythms, the Lorentz factor turns out practically 1, which implies there are no perceptible effects. Your automobile moving at 100 kilometers per hour experiences relativistic effects so microscopic they turn out totally insignificant. But as you approach the light limit, the Lorentz factor begins to increment. At 50% of the light limit, it turns out approximately 1.15. This implies your chronometer elapses approximately 15% slower than someone at rest chronometer. It doesn't seem so dramatic, correct? However, observe what occurs as you accelerate more. At 80% of the light limit, the factor is 1.67. At 90% it's 2.30, at 95% it's 3.2, at 99% it's 7.1. You already managed to perceive the tendency. The figures begin to increment more and more fast. At 99.9% of the light limit, the Lorentz factor turns out 22.4. At 99.99% it turns out 70.7, and herein lies the mortal dilemma. For intergalactic journeys to be feasible within a human existence, you demand enormous Lorentz factors. Andromeda is at 2.5 million light-years of separation. If you go at 50% of the light limit, it requires 5 million years according to terrestrial time. Useless. Even at 99% of the light limit, it turns out approximately 2.5 million years of terrestrial time, although for you they would represent approximately 350,000 years thanks to chronological dilation. Still totally unviable. To reduce the journey duration to something remotely practical, let's suppose 100 years of subjective time for the crew, you would demand a Lorentz factor of approximately 25,000. This corresponds to a rhythm of 99.9999998% of the light limit. And here is where relativistic physics plunges the dagger. The power required to achieve that rhythm turns out absolutely prohibitive. Remember the relativistic kinetic power formula. At reduced rhythms, power turns out simply half the mass. Multiplied by the rhythm squared, elementary, linear, manageable, but at relativistic rhythms the formula metamorphoses. Relativistic kinetic power constitutes mass multiplied by c superscript 2 multiplied by the Lorentz factor -1. And when the Lorentz factor turns out 25,000, you're multiplying your vehicle's mass by 25,000 times the light limit squared. The figures become obscene. For a 1,000-ton vehicle, the power required to achieve a Lorentz factor of 25,000 turns out approximately 2.2 times 10 to the 24th joules. To put it in context for you, that represents approximately the power our star radiates in 2 entire weeks. You would demand to capture all our star's power for 2 weeks and channel it impeccably into accelerating your vehicle. And that represents only to accelerate. You demand identical magnitude to decelerate, and this presumes perfect efficiency, something physically unviable. In practice, with the efficiencies we manage to obtain, you would probably demand 100 times more power. We are referring to our star's complete generation for almost 3 years for a single ship, a single journey. However, even if we could magically solve the energy dilemma, relativity possesses other unpleasant surprises awaiting us. One of the most disturbing constitutes the twin paradox, amplified to intergalactic magnitude. Do you know the elementary version? One twin moves to the cosmos at relativistic rhythms while the other remains on our planet. When the explorer returns, they have aged less than the twin who remained at the origin. It constitutes an authentic effect verified experimentally 1,000 times. Now amplify this to an intergalactic journey. Visualize that you depart toward Andromeda with a Lorentz factor of 25,000. For you, the journey requires 100 years. You experience an entire existence exploring during the journey. Perhaps you have offspring, even grandchildren. Finally, you determine to return to the origin. Another century of subjective time, 200 years total for you. However, when you return to our world, approximately 5 million years have elapsed. 5 million. The civilization you knew no longer remains. The language you speak turns out incomprehensible. Your friendships, family, your entire species as you knew it, everything has disappeared eons ago. The continents have moved, species have evolved. Our planet you abandoned constitutes literally an alien planet. Currently, there is no return to the origin. Technically, you return to the identical world, But that world has mutated so much you could equally remain on another planet. You constitute a temporal specter, a living anachronism, someone totally disconnected from their own epoch. This doesn't constitute speculative fantasy, it constitutes a direct mathematical implication of Einstein's formulas. Inevitable, inescapable, definitive. There is also the dilemma of relativistic mass. As you accelerate, your effective mass increments by the Lorentz factor. This doesn't imply you acquire additional particles, but that your inertia increments. It becomes more and more arduous to accelerate more. At 99.99% of the light limit, your effective mass turns out 70 times superior to your rest mass. This implies that any power you try to apply to accelerate more must overcome 70 times more inertia, and this generates destructive feedback. You demand more power to accelerate more, but as you accelerate, your effective mass increments, which demands still more power to accelerate, which increments your effective mass still more. It constitutes an exponential curve that shoots toward infinity. As you approach the light limit, your effective mass approaches infinity, and the power required to provide you even a diminutive additional acceleration also approaches infinity. This doesn't constitute rhetorical exaggeration, it turns out mathematically textual. At the threshold where your rhythm approaches c, the light limit, your effective mass diverges toward infinity. It would demand infinite power to accelerate a body with mass to precisely the light limit. Infinity, not a colossal figure, textually infinity. The cosmos has installed an infinite power barrier precisely at that threshold, ensuring you never manage to traverse it. And there's more. At extremely relativistic rhythms, the cosmos in front of you begins to behave in peculiar ways. The photons from the cosmic microwave background, normally innocuous, with temperatures of barely 2.7 Kelvin, experience such an extreme blue shift that they metamorphose into mortal gamma radiation. With a Lorentz factor of 25,000, these photons would arrive at your vehicle with powers equivalent to high-power gamma rays, constantly bombarding you with lethal radiation. Technicians have estimated you would demand shielding of various meters thickness of dense materials only to protect yourself from this radiation. However, those shields possess mass, and that additional mass demands more power to accelerate and more mass for propellant and more shields to protect that propellant. It constitutes another destructive spiral without elegant resolution. Even interstellar dust, normally invisible and insignificant, metamorphoses into a mortal risk at extreme relativistic rhythms. A dust particle the volume of a grain of sand impacting your vehicle at 99.99% of the light limit would release power comparable to various atomic bombs. Each fragment of dust potentially constitutes a catastrophic detonation. You would demand to detect and dodge them constantly, or possess shields so massive and resistant that the additional weight would make the journey unviable. Then there's the dilemma of relativistic orientation. At rhythms close to the light limit, the stars in front of you seem to agglomerate into a resplendent circle due to light aberration. The stars behind you fade. Your perception of the complete cosmos distorts. Computing trajectory becomes extraordinarily intricate, since you must compensate not only for the displacement of your goal during the journey, but also for relativistic effects on your perception of space-time itself. All this supposes you manage to propel and stop gradually. However, human beings only withstand a determined magnitude of thrust before perishing, about 3 to 4 times Earth's gravitational force maintained during extensive lapses to propel to 99.9999% of the light ceiling with a thrust of 3 gravities would consume about 1 year. It sounds feasible, however that year of thrust requires colossal volumes of fuel burning uninterruptedly, and subsequently you need another year of braking upon reaching the destination and identically for the return. 4 years in total of thrust and braking for a single complete journey. Throughout that period you're consuming fuel at astonishing rhythms. The numbers reveal that for an entire journey toward Andromeda and back, even with impeccable matter-antimatter propulsion, you would need to carry about 99.99% of your spacecraft's mass as fuel. Only 0.01% could constitute operational payload, personnel, equipment, everything additional. This indicates that to obtain a habitable compartment of 1,000 tons you would need a spacecraft with starting mass of approximately 10 million tons. 10 million tons. For reference, the largest vessel ever manufactured, the supertanker Seawise Giant, reached about 650,000 tons. You would need to manufacture something 15 times more colossal than the most tremendous vessel in our history, only this should operate in spatial nothingness, withstand extreme emissions and consume antimatter in impeccably regulated form for years. Relativity doesn't turn out merciless. Relativity turns out totally neutral. The same formulas that wonderfully explain how the cosmos operates, that prognosticate with impeccable exactitude the conduct of everything, from subatomic components to black holes, constitute the same formulas that perpetually seal the entrances to intergalactic journeys. Not because Einstein declared negatively, but because the mathematical architecture of the spatiotemporal continuum itself declares negatively. And these relativistic walls suppose we manage to manufacture the spacecraft, produce the energy, and resolve all engineering challenges. But there exists an ultimate impediment we haven't examined yet. An impediment without any relation to physics or mathematics or engineering. An impediment localized within ourselves. Our delicate organisms developed to flourish on the surface of a particular world, enveloped by a guardian electromagnetic field, flooded in emissions from a particular star. Organisms that upon extracting them from that perfect environment and projecting them to the intergalactic precipice, simply collapse. We have examined unreachable distances, exorbitant energies, fractured transmissions, and a cosmos dilating to distance us from our goals. We have examined the walls of relativity that transform time itself into an adversary, but there persists an ultimate wall that represents perhaps the most intimate, the most individual, the most crushing of all. A wall absent in the stars, absent in the formulas, absent in the restrictions of fuel, present in our own organisms. Human beings evolved throughout millions of years in an extraordinarily particular environment. The terrestrial surface flooded by emissions from a Category G star, safeguarded by a planetary electromagnetic field deflecting mortal charged components enveloped by a gaseous layer filtering more harmful ultraviolet rays with an exact gravitational force of 9.8 meters per second squared. Each cellular component of your organism, each biological apparatus, each metabolic procedure is calibrated for these precise circumstances. And upon abandoning that guardian environment, upon penetrating into deep nothingness and particularly into the intergalactic precipice, your organism begins to collapse in modalities simultaneously inevitable and terrifying. Let's initiate with emissions. On our planet you're safeguarded by two imperceptible barriers, but absolutely essential. The terrestrial electromagnetic field deflects the majority portion of stellar flux, those charged components that our star constantly expels toward nothingness. The gaseous layer absorbs cosmic emissions, those high-power protons and atomic nuclei precipitating constantly from deep nothingness. Jointly, these barriers minimize your contact with emissions to thresholds your organism manages to handle, that your DNA manages to restore. In interplanetary nothingness, let's suppose in a Martian journey, you sacrifice atmospheric safeguarding, but still conserve certain safeguarding from the stellar electromagnetic field. Contact with emissions elevates dramatically. Astronauts in the International Space Station absorb about 50 to 200 times more emissions than on the terrestrial surface, sufficient to considerably elevate their carcinogenic probability, but tolerable for expeditions of some months. In interstellar nothingness, you sacrifice even the safeguarding of the stellar electromagnetic field. Cosmic emissions impact you without filtration, but at least you still remain within our Milky Way, where the galactic electromagnetic field supplies certain minimal safeguarding. Investigations by the North American Space Agency calculate that an interstellar journey of decades would subject astronauts to emission dosages practically assured to generate cancer. But in intergalactic nothingness, all this vanishes. No galactic electromagnetic field safeguards you. No stellar heliosphere exists. No protection, except absolute nothingness and unfiltered emissions emanating from all orientations. Cosmic rays of powers so elevated they manage to penetrate meters of armor. Components capable of fragmenting atomic nuclei in your cells, generating secondary avalanches of even more harmful emissions. The numbers turn out merciless, even with various meters of aquatic armor or polyethylene, substances relatively effective blocking emissions. An intergalactic traveler would absorb cumulative dosages annihilating their spinal marrow, collapsing their immune apparatus and ensuring multiple aggressive malignant tumors. And that supplementary armor possesses mass. Mass that needs to be propelled, mass that makes the energy challenge even more unreachable. Some have proposed employing synthetic electromagnetic fields to deflect charged components, basically replicating the terrestrial electromagnetic field surrounding the spacecraft. But the required fields should be tremendous, in the range of kilometers in diameter, and would require colossal volumes of energy to sustain uninterruptedly for millions of years and would only safeguard against charged components. Gamma rays, neutrons, other modalities of uncharged emission would traverse directly any electromagnetic field as if it were absent. Subsequently, there's the challenge of temporal lapse. Even if we could protect you impeccably from emissions, even if we could create an impenetrable barrier, intergalactic journeys consume an incomprehensibly extensive lapse. We have examined the millions of years required even at relativistic velocities. And human beings don't endure millions of years, we endure decades, 80 years if we have fortune. The evident answer constitutes hibernation or animated suspension. Cryogenize the crew, place them in some modality of metabolic stasis, reanimate them upon reaching destination. Speculative narrative presents it simply. Reality turns out devastatingly more intricate. We have managed to preserve cellular components, diminutive tissues, even some organs through cryopreservation. But an entire human, an integrated apparatus of interdependent organs with a brain containing 86 billion neurons each with thousands of synaptic links, turns out incomparably more intricate. Upon cryogenizing living tissue, the liquid inside cells generates frozen crystals perforating cellular envelopes like microscopic sheets. Cells explode. The tissues disintegrate. Experts have developed chemical cryoprotectors preventing the generation of frozen crystals. They operate reasonably well for diminutive specimens. But for an entire human organism, you would need to perfuse these compounds through each tissue, substitute all the liquid in each cell. And these compounds turn out toxic in elevated concentrations. The dosage required to totally safeguard would probably annihilate you before you could be cryogenized. Even if we solved the cryogenization challenge, the reanimation challenge turns out equally arduous. You need to heat the organism in impeccably uniform form. If some portions heat faster than others, temperature gradients generate colossal structural tension, tissues fracture, organs collapse, and the brain, the most delicate structure of all, would turn out particularly vulnerable. Your memories, your individuality, everything that constitutes you is stored in extraordinarily fragile patterns of synaptic links. A single failure in the reanimation procedure could annihilate them irreversibly. And this supposes the hibernation procedure executes a single time. You cryogenize, you move, you reanimate. But in a journey of millions of years, inevitably challenges will emerge requiring intervention, apparatus collapses, meteoroid deterioration, need for course rectifications. Someone needs to be conscious to manage urgencies, which implies multiple cycles of cryogenization and reanimation. Each cycle accumulates more deterioration. After dozens or hundreds of cycles throughout millennia, the cumulative deterioration would probably turn out mortal. Alternatively, you could possess multigenerational spacecraft so tremendous that an entire population inhabits, multiplies and perishes during the journey. The great-great-grandchildren of the great-great-grandchildren of the great-great-grandchildren of the original crew finally reach the destination, but this introduces a totally divergent set of biological challenges. To sustain a genetically viable population for millions of years, you would probably need at least various thousands of individuals. Any inferior population would suffer consanguineous depression, accumulation of deleterious mutations, eventual genetic collapse, and those thousands of individuals need food, liquid, oxygen, habitable space. You need entire and sealed ecosystems capable of recycling all resources for eons without collapse. A single collapse in aquatic recycling or in alimentary generation and the entire population perishes. Experiments in sealed biospheric apparatus here on our planet have turned out consistently discouraging. Biosphere 2, the most ambitious experiment of this category, collapsed after only 2 years. Oxygen descended to dangerous thresholds. Carbon dioxide ascended. Species began to become extinct, and that involved only 8 individuals in a relatively ample and well-structured environment with our planet right externally if something failed. Now visualize sustaining a sealed ecosystem for not 2 years, but 2 million years for 100,000 human generations. The probabilities that no catastrophe occurs during that lapse turn out statistically equivalent to 0. An epidemic annihilating a vital crop, a mutation in recycler bacteria making them ineffective, a cascade where one apparatus collapsing triggers the collapse of others. Any of these failures would constitute the term of the entire mission. But even supposing impeccable ecosystems, there persists the psychological challenge. Human beings didn't evolve to inhabit confined enclosures for generations. We evolved as nomads in open enclosures, with distant horizons and changing celestial vaults. Prolonged confinement generates depression, anguish, psychotic disorders. Investigations in atomic submarines, Arctic installations, maximum security penitentiaries all reveal the same pattern. Prolonged confinement degrades psychological health, even in the most balanced individuals. And we are referring to confinement for not years or decades, but for the entire existence of thousands of generations. Infants being born in a spacecraft inhabiting their entire existence without ever observing an authentic horizon, without perceiving precipitation, without walking on solid surface, and subsequently perishing understanding that their offspring will experience precisely the identical. The probability of community collapse, insurrection, violence turns out extraordinarily elevated. Some psychological investigations suggest that after various generations the population would lose even the motivation to continue the expedition. Why should the great-great-grandchildren of the initial crew members worry about reaching a destination they will never perceive, pursuing the aspiration of ancestors who perished centuries ago? It turns out probable they would finally reject the expedition, modify the course, or simply permit the apparatus to collapse because the notion of a destination has become abstract and devoid of meaning. There also persists the challenge of evolution. During millions of years in a synthetic environment, human beings would inevitably evolve. Natural selection would privilege characteristics adapted to the spacecraft environment, not to the destination environment. By the time they arrived, if they arrived at all, they could constitute a totally divergent species. Their organisms adapted to synthetic gravity, their eyes adapted to synthetic luminosity, their immune apparatus never exposed to natural pathogens, would turn out incapable of enduring in an authentic world, even if they found one. And subsequently, there's the most essential challenge of all: purpose. Intergalactic journeys would consume so much lapse that the civilization initiating them would not resemble at all the civilization benefiting from them. Spacecraft launched currently would arrive at an era where humanity, as we know it, probably wouldn't remain, substituted by posthumans, synthetic intelligences, or perhaps nothing at all if we become extinct meanwhile. Does it possess sense to invest astronomical resources in an expedition benefiting entities so distanced from us in time and evolution they would turn out effectively alien? Does it possess sense to sentence generations of humans to inhabit and perish in transit to reach an objective they perhaps don't even remember why it turned out crucial? Human biology doesn't constitute a technical impediment we manage to engineer around. It constitutes an essential restriction that reflects the fact we constitute products of a particular world evolved for eons to prosper in extraordinarily particular circumstances. Extracting ourselves from those circumstances for cosmological periods doesn't constitute exploration, it constitutes a slow modality of extinction. Each apparatus in your organism is clamoring we weren't structured for this, that our place remains here, on this world, under this star, safeguarded by these electromagnetic fields, that the aspirations of transforming ourselves into intergalactic nomads turn out fundamentally incompatible with the reality of what we constitute as biological organisms. And all these biological barriers operate jointly with the physical barriers we already examined. They don't constitute separate challenges you manage to resolve one by one. They constitute interwoven aspects of a single devastating truth. The cosmos, in its essential architecture, ensures that biological species remain confined to their originary galaxies. Separations turn out unreachable, energies turn out exorbitant, communication breaks, void dilates, relativity imposes absolute thresholds, and our own fragile organisms collapse under the circumstances of deep void. But perhaps there persists a diminutive hope in all this despair. Perhaps if we could at least assimilate totally how colossal the cosmos turns out, how insignificant we turn out in its magnitude, we could find certain consolation. So let's explore precisely that, the merciless reality of cosmic separations and what they truly imply when you cartograph them with merciless exactitude. There persists a cause for which astronomers employ terms like light year or parsec instead of kilometers. It doesn't constitute scientific pretension nor superfluous jargon. It turns out because the figures in kilometers become so absurdly tremendous they lose all significance. When you express that Andromeda remains at 24 quintillion kilometers of separation, your brain simply doesn't manage to process. That constitutes a figure without context, without magnitude, without emotional significance. But when you truly assimilate what that separation implies, when you cartograph it against what we truly manage to execute, despair becomes palpable. Let's initiate with something we manage to assimilate. Our lunar satellite remains approximately 384,400 kilometers from our planet. Humans have remained there. 12 individuals have walked upon its surface. The journey consumed approximately 3 days with the technique of the 1960s. It turns out distant, but reachable. It constitutes the only frontier in the void we have truly traversed with our own organisms. Mars, our next objective, remains on average at about 225 million kilometers, approximately 586 times more distant than our satellite. With present technique, a crewed journey would consume between 6 and 9 months. It turns out challenging but feasible. Technicians are operating seriously on crewed expeditions to Mars. We could execute it in the next decade or two if we truly commit. Now let's execute the next leap. Proxima Centauri, the star closest to our star, remains at 4.24 light-years. That constitutes approximately 40 trillion kilometers. To put it in context, if the separation to our satellite constitutes 1 centimeter in a model magnitude, Proxima Centauri would remain at more than 3 kilometers of separation. With Voyager 1 technique, our fastest spacecraft, we would consume approximately 73,000 years to arrive. 73,000 years. All human civilization from the first cities in Mesopotamia until currently constitutes barely a third of that lapse. The most hopeful proposals of advanced propulsion, like the Breakthrough Starshot Initiative, planning to employ photonic navigation propelled by giant emitters, suggest we could transmit microscopic probes toward Proxima Centauri in approximately 20 years, moving at 20% of the light limit. Microscopic probes. Not humans, not even robots the volume of an automobile, chips the volume of your fingernail with diminutive cameras. And that constitutes the optimum we manage to conceive with known physics and an investment of billions of dollars. For a crewed expedition toward Proxima Centauri employing realistic propulsion, we are referring to journeys of various centuries, multiple generations inhabiting and perishing in transit. And that represents only to reach the closest star, only to traverse approximately 0.0004% of our Milky Way's diameter. Our Milky Way possesses approximately 100,000 light-years in diameter. We remain located at approximately 26,000 light-years from the galactic nucleus in one of the spiral arms. If we desired to move to the opposite extreme of our own galaxy, let's suppose 80,000 light-years of separation, with Breakthrough Starshot technique it would consume 400,000 years. 400,000 years. Neanderthals wandered through Europe 400,000 years ago. Homo sapiens as a species barely possesses 300,000 years of permanence. And remember, that turns out within our galaxy. That constitutes our cosmic backyard. Now let's leap to the intergalactic precipice. Andromeda, at 2.5 million light-years, turns out approximately 25 times more distant than the entire diameter of our Milky Way. If our entire galaxy possessed the volume of a euro coin, Andromeda would remain at more than 2 meters of separation, and the void between both doesn't constitute normal void. It constitutes an almost perfect void, the most void existing in the cosmos. The concentration of matter in intergalactic void turns out approximately 1 atom per cubic meter. In some places, 1 atom per various cubic meters constitutes void of a purity we could never replicate in a laboratory. To reach Andromeda with starshot technique would consume 12.5 million years. Since the first primates began to evolve in Africa until currently approximately 25 million years have elapsed. You would demand half of all that evolutionary lapse to execute that journey. By the time you arrived, if something arrived, humans would have evolved into something totally unrecognizable or would have become extinct long ago. But Andromeda constitutes the anomaly. It forms part of our local assembly, a conglomerate of approximately 54 galaxies gravitationally linked to each other. The local assembly possesses approximately 10 million light-years in diameter. Within this assembly there persist perhaps half a dozen galaxies we could theoretically orient with spacecraft. The Triangle Galaxy at 3 million light-years. The Magellanic Clouds, dwarf satellite galaxies of our Milky Way, at 163,000 and 200,000 light-years, respectively. These constitute our cosmic neighbors, our immediate galactic family, and even so they remain so incomprehensibly distant that reaching them would require techniques grazing the thresholds of theoretical physics and temporal lapses that exceed our species' trajectory. More distant from the local assembly, separations become truly cosmic in their magnitude. The closest galaxy cluster constitutes the Virgo cluster, at approximately 65 million light-years. It contains approximately 1,300 galaxies. With starshot technique, you would consume 325 million years to reach it. Dinosaurs dominated our planet for approximately 165 million years. You would demand almost double that entire period to execute that journey. And Virgo constitutes our local supercluster. More distant there persist other superclusters, each containing tens of thousands of galaxies, separated by cosmic voids of hundreds of millions of light-years of extension. The Coma supercluster at 330 million light-years. The Great Attractor, a gravitational anomaly toward which our local assembly moves at approximately 250 million light-years. Shapley, the most massive supercluster in our near cosmos, at approximately 650 million light-years. These places turn out so distant that the luminosity we perceive from them departed when dinosaurs still dominated our world, when the first mammals constituted rodent-volume creatures hiding in refuges. We are perceiving the deep past of those places, and reaching them would require techniques and temporal lapses that turn out simply incompatible with any meaningful concept of civilization or even of biological species. And all this still remains within the near cosmos. The observable cosmos possesses a radius of approximately 46,500 million light-years. That turns out due to void dilation. The luminosity of objects currently at that separation has consumed 13,800 million years to reach us, almost the entire age of the cosmos. But those objects have distanced themselves due to dilation while their luminosity traveled. But remember the Hubble horizon we examined previously. More distant from approximately 4,600 million light-years, galaxies distance themselves faster than even luminosity manages to move to reach them. Approximately 94% of galaxies in the observable cosmos remain more distant from that horizon. They turn out observable in the sense that we manage to perceive their ancestral luminosity, but they turn out unreachable in any practical sense. Astronomers employ something denominated the cosmic distance ladder to quantify these colossal extensions. It constitutes a hierarchy of methods, each calibrated against the precedent, each extending our reach a bit more distant. Stellar parallax for close stars, variable Cepheids for nearby galaxies, category Ia supernovae for cosmological separations. And each rung on this ladder unveils that the cosmos turns out even more colossal than the precedent rung suggested. There persists something profoundly humiliating in cartographing the cosmos with exactitude. It doesn't turn out only that we turn out diminutive, although we do. It turns out that we remain trapped in a minuscule region of an incomprehensibly colossal cosmos, without any conceivable modality to escape from that region. It turns out comparable to discovering you inhabit on a diminutive island in an infinite ocean, except this ocean is constituted of mortal void and is actively dilating to ensure you never manage to swim toward another island. There persist approximately 2 trillion galaxies in the observable cosmos. 2 trillion. Each containing hundreds of billions of stars. Each star potentially with worlds. The figure of potential worlds turns out so colossal we literally can't assimilate it. And of all those worlds, of all those possibilities, our species possesses meaningful access to precisely one, our planet. With extreme effort and advanced technique, perhaps we could colonize some other bodies in our planetary system. Mars, probably, perhaps satellites of Jupiter or Saturn. With extraordinary fortune and multiple technological leaps, perhaps we could transmit multigenerational spacecraft towards some close stellar systems, establishing diminutive colonies that would probably perish or evolve into something not human. And with techniques grazing the unviable and resource commitments exceeding everything our civilization has ever executed, perhaps, only perhaps we could transmit expeditions toward other galaxies in the local assembly. Expeditions consuming millions of years, that would totally fracture communication with the origin, that would turn out essentially irrelevant to the civilization that launched them. This constitutes the map of our prison. A pale blue dot suspended in a solar ray, as Carl Sagan denominated it, enveloped by a planetary system we could marginally explore, contained within a galaxy we could theoretically navigate for millions of years, and that galaxy floating in a local assembly marking the absolute thresholds of any conceivable expansion. More distant from those thresholds, the cosmos continues in magnitudes making our most tremendous figures look trivial. But for us, for any biological civilization restricted by the principles of physics, those extensions could equally turn out infinite. They turn out unreachable, not because we lack technique, although we do lack it, but because the essential principles of the cosmos ensure they remain perpetually out of reach. And yet, despite all this despair, despite all these invincible barriers, humanity continues fantasizing about the stars, continues imagining warp drives and wormholes and dimensional shortcuts permitting us to mock these restrictions. It continues clinging to the expectation that speculative narrative will finally metamorphose into scientific reality. So let's examine those expectations one by one and perceive if any manage to endure the encounter with authentic physics. For decades, speculative narrative has marketed us a vision of the future where humanity escapes from its planetary prison and expands through the cosmos. Star Trek exhibited us the warp drive. Star Wars provided us hyperdrive. Battlestar Galactica presented us instantaneous superluminal jumps. Interstellar seduced us with transcitable wormholes. These narratives turn out beautiful, inspiring, filled with expectation, and all, absolutely all, depend on physics that turns out either totally unviable or so profoundly improbable we could equally denominate it sorcery. It doesn't constitute the fault of the narrators. Their labor consists of narrating exciting stories, not imparting physics lessons, but they have generated generations of individuals genuinely believing that intergalactic journeys constitute only a question of lapse and technological development, that we will finally discover the trick, the juridical loophole in the principles of the cosmos permitting us to mock the restrictions. So let's examine the most popular resolutions of speculative narrative and perceive why each collapses when you confront it with authentic physics. Let's initiate with the most iconic, Star Trek's warp drive. The notion turns out elegant. Instead of moving the spacecraft through the void, you contract the void in front of you and dilate the void behind you. You generate a bubble of spatiotemporal continuum carrying you with it while you surf a wave of distorted void. Technically, you don't move faster than luminosity through the void, so it doesn't contravene relativity. The void itself moves and you go with it. This notion doesn't turn out totally invented. In 1994, physicist Miguel Alcubierre published a document demonstrating that Einstein's general relativity formulas technically make possible this spatiotemporal continuum geometry. The document generated excitement because it seemed we finally possessed a mathematical resolution for superluminal journeys that didn't openly contravene known principles. But the enthusiasm endured little. When physicists examined the formulas more closely, they discovered devastating dilemmas. The first constitutes power. To generate a warp bubble the volume of a spacecraft, Alcubierre's formulas demand magnitudes of negative power equivalent to the mass power of entire Jupiter. Negative power. We are not referring to antimatter, which constitutes conventional matter with opposite charge. We are referring to power with negative concentration, something possessing negative pressure and repulsive gravitational attraction. Negative power persists. Technically, there persists a quantum phenomenon denominated the Casimir effect, producing minuscule magnitudes of something behaving like negative power. Two metallic plates extraordinarily close in the void experience an attractive power due to quantum fluctuations, but the magnitudes turn out ridiculously diminutive in the range of piconewtons. And nobody possesses notion of how to amplify this to macroscopic magnitudes, much less to Jupiter's mass power. But let's suppose you magically manage to produce negative power. The second dilemma constitutes causality. Subsequent analyses of Alcubierre's metric demonstrate it inevitably generates closed chronological curves, loops in time making possible contraventions of causality. You could reach your destination before departing. You could constitute your own ancestor. The cosmos fills with logical contradictions, fracturing the elementary coherence of existence. Physicists generally consider there persists something denominated the chronological protection conjecture. The cosmos possesses built-in mechanisms preventing causality contraventions. Physics principles conspire to make chronological machines unviable and any technique making possible temporal contradictions. If that turns out authentic, and all evidence suggests it does, subsequently warp drives turn out physically unviable, not because they contravene special relativity, but because they contravene something still more essential, the causal architecture of the spatiotemporal continuum. There also persists a third practical dilemma. Even if you could generate a warp bubble, you couldn't regulate it from the interior. The formulas demonstrate that once remaining inside the bubble, you remain causally disconnected from the exterior. You can't transmit transmissions forward to direct the bubble. You can't propel or stop. You can't modify orientation. You would remain trapped in an unregulated bubble, sliding through the void, without modality to stop or maneuver. It doesn't turn out precisely profitable for orientation. Well, the warp drive is discarded. What persists of wormholes? The notion constitutes that the spatiotemporal continuum manages to curve in such a way that two distant regions link through a passage. You move through the wormhole and emerge instantaneously in a distant place. It turns out comparable to curving a sheet of paper and perforating an orifice through both layers simultaneously. Wormholes truly emerge from Einstein's general relativity formulas. They constitute mathematically valid resolutions, but there persist various catastrophic dilemmas making them useless for journeys. First, natural wormholes, if they remain, would turn out microscopic and ephemeral. They would generate and collapse in fractions of an instant at quantum magnitudes. To generate a wormhole transitable by humans, you would demand to stabilize it. And the only known modality to stabilize a wormhole constitutes filling its throat with enormous magnitudes of exotic substance, specifically that negative power we already examined. Again, the required magnitudes turn out astronomical, probably equivalent to the mass of multiple stars. Second, even if you could stabilize a wormhole, traversing it would turn out mortal. The extreme curvature of the spatiotemporal continuum in the throat would generate tidal powers stretching you like noodles. You would demand to manufacture the wormhole so extraordinarily tremendous that tidal powers become tolerable, which demands still more exotic power. Third, and perhaps more devastating, you can't simply generate a wormhole connecting two arbitrary points in the void. Wormholes link regions of the spatiotemporal continuum that already remain connected in some form in the void's architecture. To generate a wormhole between our planet and Andromeda, you would first demand to physically drag one of the wormhole's extremes to Andromeda by conventional methods, which implies the first journey still consumes millions of years. The wormhole only turns out profitable for subsequent journeys, and finally, like warp drives, transitable wormholes inevitably make possible time travel and causality contraventions. If you possess a transitable wormhole, you manage to transform it into a chronological machine by moving one of the extremes at relativistic rhythms, which probably implies the chronological protection conjecture makes them unviable. What persists of hyperspace or supplementary dimensions? The notion constitutes that supplementary dimensions of the void remain beyond the three we experience, and that by moving through these supplementary dimensions you could execute shortcuts. It turns out comparable to walking on a sphere's surface versus perforating directly through the interior. Contemporary theoretical physics, specifically string theory, suggests supplementary dimensions could remain. But there persists a dilemma. These dimensions remain compactified, rolled up on themselves at extraordinarily diminutive magnitudes, probably around Planck length, 10 to the minus 35th meters. That constitutes approximately 1 million trillion times more diminutive than a proton. These dimensions turn out so microscopic that only essential particles manage to perceive or interact with them. Macroscopic objects like you or a spacecraft simply don't fit in these dimensions. It would turn out comparable to trying to introduce a continent through a needle's orifice that turns out 1 billion trillion times more diminutive than an atom. It doesn't constitute an engineering restriction, it constitutes an essential geometric restriction. Some have speculated regarding ample supplementary dimensions, sufficiently ample so macroscopic objects manage to access them, but we possess no evidence of such dimensions, and their permanence would generate observable effects in gravitational attraction we don't perceive. Experimental tests have established progressively more rigorous thresholds regarding how ample supplementary dimensions could turn out to be detected. And those thresholds turn out currently so diminutive they turn out useless for journeys. What persists of tachyons? Hypothetical particles moving faster than luminosity. If they remain, perhaps you could employ them for superluminal communication or propulsion. The dilemma with tachyons constitutes that they turn out mathematically consistent only if they never interact with conventional substance. The instant a tachyon interacts with something, it generates causality contradictions. Tachyons could transport information toward the past, making possible that effects precede their causes. The majority of physicists consider tachyons simply don't remain, precisely because they would generate these causality contraventions. Even if they remained, they wouldn't assist you. You can't accelerate conventional substance beyond the light limit to transform it into tachyons. There persists an insurmountable barrier at the light limit. Tachyons, if they remain, would have emerged moving faster than luminosity and could never decelerate below it. They constitute totally separated and inaccessible objects from our subluminal observation point. What persists of manipulating the quantum void? Some speculative documents suggest the quantum void, distant from turning out truly void, constitutes a sea of virtual particles appearing and fading constantly. Perhaps you could extract power from the void or manipulate it to generate propulsion. The dilemma constitutes that the quantum void remains in its most reduced feasible power state. It turns out comparable to trying to extract liquid from a lake that already remains at the most reduced feasible point. There persists no net power you manage to extract. The Casimir effect we alluded to previously doesn't generate power from nothing, it simply redistributes the zero-point power that already remains. And the magnitudes turn out so minuscule they turn out totally useless for propulsion. Each proposed resolution finally crashes against the identical wall. The essential principles of physics don't constitute principles in the sense of regulations that could be modified. They constitute descriptions of how existence operates at its most elementary level. Contravening them doesn't turn out comparable to breaking a norm, it turns out comparable to trying to trace a triangle with 4 sides or generate a married bachelor. It constitutes a logical contradiction, not only a technical challenge. Speculative narrative deceived us not by malice, but by narrative necessity. Narratives about individuals perpetually trapped in a single planetary system don't turn out as exciting as narratives about galactic empires. But the implication of generations of these narratives constitutes that millions of individuals genuinely consider intergalactic journeys turn out inevitable, only a question of lapse and progress. The truth turns out harder, but also more beautiful in its own modality. The cosmos doesn't remain structured for our convenience. It wasn't generated for us to explore freely. The same principles making possible that atoms remain, making possible that chemistry remains, making possible that existence remains, constitute the principles ensuring our galactic confinement. There persists no juridical loophole. There persists no ingenious trick. There persists no future technological resolution. The entrances remain closed. Not with locks we manage to force, but with the essential mathematical principles of existence itself. And those principles don't modify themselves, don't negotiate, don't execute exceptions. So, what remains for us? If intergalactic journeys turn out unviable, if all the speculative technique of speculative narrative constitutes fantasy, if we remain truly sentenced to remain in our galaxy perpetually, what constitutes the significance of all this? Does this revelation constitute a cosmic catastrophe, or could it turn out, paradoxically, the optimum news our species could receive? We have traveled a dark path jointly. We have confronted separations defying assimilation, powers exceeding the feasible, communications breaking in cosmic silence, a cosmos actively dilating to distance us from our destinations. Relativistic thresholds closing all entrances, biological organisms collapsing under the circumstances of deep void, cartographies unveiling our cosmic insignificance, and technological fantasies crumbling under authentic physics scrutiny. It turns out simple to perceive all this as a catastrophe, as a perpetual prison sentence dictated by an indifferent cosmos, as the term of the grandiose human narrative of exploration and finding. We transit from considering we constituted the cosmos nucleus to understanding we constitute conscious prisoners on a cosmic island from which we will never manage to escape. It turns out devastating, it turns out humiliating, it turns out definitive. But there persists another modality to perceive this truth, a modality transforming despair into something unexpectedly beautiful. Because our galactic prison doesn't constitute a diminutive and claustrophobic cell, it constitutes a kingdom so colossal, so rich in possibilities, so filled with unresolved enigmas, we could literally explore it for millions of generations without exhausting ourselves of marvels to discover. Our Milky Way contains approximately 400 billion stars. 400 billion, each potentially with worlds. Conservative estimations suggest there persist at least 100 billion worlds in our galaxy, and we are not referring to inert rocks floating in the void. Recent exoplanet investigations suggest approximately 20% of stars similar to our star possess worlds in the habitable zone, regions where liquid can remain. That implies approximately 20 billion potentially habitable worlds only in our galaxy. 20 billion opportunities to find existence, to discover alien ecosystems, to find perhaps civilizations with which we could communicate within reasonable temporal lapses. If only one of every 1,000 of those habitable worlds developed complex existence, we would be referring to 20 million living worlds. And if only one of every 1,000 of those developed technological intelligence, there would still persist 20,000 civilizations in our galaxy. We don't demand to escape from our Milky Way to find cosmic company. We demand to observe more carefully our own neighborhood. And that neighborhood turns out incomprehensibly colossal. Even moving toward the closest star would consume decades with advanced technique. Totally exploring only our local galaxy sector, let's suppose a radius of 1,000 light-years, would require millions of expeditions for thousands of years. It constitutes labor for 1,000 civilizations for 1,000,000 years, and this supposes we only remain interested in worlds. But our Milky Way remains filled with other fascinating phenomena. Nebulae where stars emerge, stellar generation regions so colossal they contain sufficient material for millions of suns. Binary apparatus where stars orbit in intricate gravitational dances. Neutron stars spinning hundreds of times per second with electromagnetic fields so intense they distort atoms themselves. Black holes with masses of millions or billions of suns where physics principles behave in modalities we barely begin to assimilate. In our galaxy's nucleus remains Sagittarius A star, a supermassive black hole with approximately 4 million times our star's mass. It constitutes a natural laboratory to investigate extreme gravitational attraction, relativistic physics, and the thresholds of our theories. Reaching it with conventional spacecraft would consume tens of thousands of years, but it remains within our galaxy. It turns out accessible in principle, it constitutes part of our home, and subsequently there remains the entire architecture of our Milky Way. It constitutes a barred spiral galaxy with arms extending from a dense central nucleus. It contains regions of divergent ages, divergent metallicities, divergent evolutionary trajectories. Exploring how stellar generation varies in divergent portions of the galaxy, how chemical compositions evolve, how dark substance distributes. All these constitute enigmas requiring centuries of observation and exploration to decipher, but perhaps the most compelling argument to accept our galactic thresholds possesses no relation with what we manage to find out there, but with what we manage to constitute here. Human trajectory until currently has constituted a narrative of constant expansion from Africa to the planet, from continents toward oceans, from our world to the void. And each occasion we reach a new threshold, we traverse it. But currently we have reached a threshold we can't traverse, and that compels us to execute something we have never had to execute previously: stop and reflect profoundly regarding what category of civilization we desire to constitute within the thresholds we possess. For centuries we have operated under the presumption that constantly there will persist more territory to explore, more resources to capitalize, more frontiers to traverse. This mentality has conducted us to annihilate ecosystems, exhaust resources, and operate as if infinite growth turned out feasible. But the cosmos has just imparted us an essential lesson. Infinite growth doesn't turn out feasible. There persist absolute thresholds inscribed in existence's architecture. Accepting our galactic thresholds implies accepting we must assimilate to prosper within finite frontiers, that we must develop a sustainable civilization, not because it turns out morally superior, but because it turns out physically imperative. There persists no alternative planet in another galaxy to which we manage to flee if we ruin this one. There persists no escape from the implications of our actions. This turns out liberating in a peculiar and paradoxical modality. It eliminates the fantasy we manage to simply relocate when circumstances become difficult. It compels us to commit totally to the space we possess, to preserve it, to manufacture something sustainable and beautiful within our thresholds. And those thresholds turn out colossal. I will never emphasize this sufficiently. We are referring to a galaxy with 100,000 light-years in diameter, 400 billion stars, 100 billion worlds. Sufficient material resources to manufacture architectures the volume of planetary systems. Available power from billions of stars. Sufficient void so billions of human individuals inhabit rich and meaningful existences. A civilization capable of capitalizing the resources of only 1% of stars in our Milky Way would constitute a Category 2.5 civilization in the Kardashev classification, regulating powers equivalent to a billion suns. It could manufacture Dyson spheres enveloping stars, capturing each photon of power they radiate. It could manufacture spatial habitats the volume of worlds. It could terraform planets, generate totally new biospheres, even engineer new modalities of existence adapted to exotic environments. The challenges of manufacturing such a civilization would keep millions of generations occupied. The dilemmas of coordination between stellar apparatus separated by light years of separation would require new modalities of governance and community structuring. The ethical challenges of interacting with alien existence, if we find it, would require wisdom we barely begin to develop. And there persists something profoundly beautiful in the notion that we remain perpetually isolated from other galaxies. It implies that any intelligent existence emerging in our Milky Way constitute our cosmic cousins. We share the identical galactic island. We remain linked by the common destiny of remaining trapped here jointly. We don't constitute competitors for intergalactic resources since such accessible resources don't remain. We constitute potentially collaborators in the project of assimilating and inhabiting our shared galaxy. The unviability of intergalactic journeys also implies that any intelligent existence we find in our Milky Way evolved here independently from us. They don't constitute invaders from other galaxies, they constitute products of the identical cosmic evolutionary process that generated us. That generates a basis for empathy and understanding that would turn out unviable with authentic aliens from other galaxies with totally disconnected trajectories. There also persists a peculiar consolation in understanding our thresholds turn out absolute. There persists no pressure to reach the unreachable. There persists no guilt for not conquering the unconquerable. We manage to relax in the certainty we have found the final thresholds, and within those thresholds manufacture something extraordinary. Our Milky Way doesn't constitute a prison. It constitutes a perfect home structured by physics principles to turn out precisely the correct volume for a technological civilization, sufficiently tremendous to contain infinite variety and enigma, sufficiently compact so communication between stars turns out feasible within human existences, sufficiently isolated from other galaxies so we develop our own unique identity without interference. And in approximately 4 billion years, Andromeda will collide with our Milky Way. Both galaxies will merge for billions of years in a chaotic gravitational dance, finally generating a single giant elliptical galaxy astronomers denominate Milkomeda or Lactomeda. That merged galaxy will contain approximately 1 trillion stars, double the worlds to explore, double the enigmas to decipher. By then, if we endure, if we prosper, if we assimilate to inhabit within our thresholds in sustainable modality, we will constitute an ancestral civilization beyond imagination. We will have possessed 4 billion years to expand through our Milky Way, to find and potentially collaborate with other modalities of intelligent existence to manufacture architectures and societies we currently can't even visualize. And when the galaxies collide, and keep in mind that stars remain so spaced that scarce direct collisions will occur, we will possess an entire new merged galaxy to explore. New stellar neighborhoods generated by the chaotic mixing, new regions of explosive stellar generation where gaseous clouds collide. New central black holes merging into one still more massive. It constitutes a totally new frontier opening automatically without necessity to contravene physics principles. The revelation that we will never abandon our Milky Way doesn't constitute the term of the human narrative. It constitutes the beginning of a new, considerably more profound and sustainable narrative. It constitutes the transition from an adolescent species considering it manages to conquer the infinite cosmos toward a mature species assimilating its thresholds and selecting to prosper within them. Thresholds don't constitute prisons when you accept them, they metamorphose into definitions of home. The walls confining us also safeguard us, define us, provide us identity. We constitute and will constantly constitute descendants of our Milky Way, emerged from its stellar dust, evolved under its luminosity, destined to explore its enigmas for as much lapse as we remain as species. This constitutes our galaxy, our home, our destiny, and it turns out more than sufficient. It turns out perfect. It constitutes everything we will ever demand. The stars we perceive in the nocturnal celestial vault don't constitute unreachable escape fantasies. They constitute our distant neighbors, patiently awaiting for us to mature sufficiently to visit them. The cosmos has provided us a lesson in cosmic humility. It has exhibited us our place, not in the nucleus, not as conquistadors of the infinite cosmos, but as conscious inhabitants of an exquisite galactic island, floating in a sea of void we will never traverse, but which we don't demand to traverse either, since within this island there persists sufficient marvels for 1 million existences, sufficient enigmas for 1 billion interrogations, sufficient void so every conceivable modality of human and post-human existence flourishes for eons. We will never abandon our Milky Way. And that doesn't constitute a catastrophe, it constitutes the most liberating truth our species could assimilate, since it implies we finally manage to cease observing outward with envy and initiate observing inward with astonishment. We manage to cease fantasizing about impossibles and initiate manufacturing the extraordinary within the feasible. Our galactic prison constitutes paradoxically the most tremendous freedom we could request, and within its absolute thresholds we will find not the term of our narrative, but its authentic beginning. If you have arrived this far on this journey through the impossible obstacles that confine us, if you have confronted these devastating truths without diverting observation, subsequently perhaps you remain prepared for the next step, to unite with those observing the cosmos, not with fantasies of unviable conquest, but with profound appreciation for the extraordinary home we already possess. Remain with us at Night Science, where we will continue exploring the thresholds of the feasible and finding beauty in the truths the cosmos unveils to us, however hard they turn out. The ethical challenges of interacting with alien existence, if we find it, would require wisdom we barely begin to develop. And there persists something profoundly beautiful in the notion that we remain perpetually isolated from other galaxies. It implies that any intelligent existence emerging in our Milky Way constitute our cosmic cousins. We share the identical galactic island. We remain linked by the common destiny of remaining trapped here jointly. We don't constitute competitors for intergalactic resources since such accessible resources don't remain. We constitute potentially collaborators in the project of assimilating and inhabiting our shared galaxy. The unviability of intergalactic journeys also implies that any intelligent existence we find in our Milky Way evolved here independently from us. They don't constitute invaders from other galaxies, they constitute products of the identical cosmic evolutionary process that generated us. That generates a basis for empathy and understanding that would turn out unviable with authentic aliens from other galaxies with totally disconnected trajectories. There also persists a peculiar consolation in understanding our thresholds turn out absolute. There persists no pressure to reach the unreachable. There persists no guilt for not conquering the unconquerable. We manage to relax in the certainty we have found the final thresholds and within those thresholds manufacture something extraordinary. Our Milky Way doesn't constitute a prison, it constitutes a perfect home structured by physics principles to turn out precisely the correct volume for a technological civilization, sufficiently tremendous to contain infinite variety and enigma, sufficiently compact so communication between stars turns out feasible within human existences, sufficiently isolated from other galaxies so we develop our own unique identity without interference. And in approximately 4 billion years, Andromeda will collide with our Milky Way. Both galaxies will merge for billions of years in a chaotic gravitational dance, finally generating a single giant elliptical galaxy astronomers denominate Milkomeda or Lactomeda. That merged galaxy will contain approximately 1 trillion stars, double the worlds to explore, double the enigmas to decipher. By then, if we endure, if we prosper, if we assimilate to inhabit within our thresholds in sustainable modality, we will constitute an ancestral civilization beyond imagination. We will have possessed 4 billion years to expand through our Milky Way, to find and potentially collaborate with other modalities of intelligent existence to manufacture architectures and societies we currently can't even visualize. And when the galaxies collide, and keep in mind that stars remain so spaced that scarce direct collisions will occur, we will possess an entire new merged galaxy to explore. New stellar neighborhoods generated by the chaotic mixing, new regions of explosive stellar generation where gaseous clouds collide. New central black holes merging into one still more massive. It constitutes a totally new frontier opening automatically without necessity to contravene physics principles. The revelation that we will never abandon our Milky Way doesn't constitute the term of the human narrative, it constitutes the beginning of a new considerably more profound and sustainable narrative. It constitutes the transition from an adolescent species considering it manages to conquer the infinite cosmos toward a mature species assimilating its thresholds and selecting to prosper within them. Thresholds don't constitute prisons when you accept them, they metamorphose into definitions of home. The walls confining us also safeguard us, define us, provide us identity. We constitute and will constantly constitute descendants of our Milky Way, emerged from its stellar dust, evolved under its luminosity, destined to explore its enigmas for as much lapse as we remain as species. This constitutes our galaxy, our home, our destiny, and it turns out more than sufficient. It turns out perfect, it constitutes everything we will ever demand. The stars we perceive in the nocturnal celestial vault don't constitute unreachable escape fantasies. They constitute our distant neighbors, patiently awaiting for us to mature sufficiently to visit them. The cosmos has provided us a lesson in cosmic humility.